Today we're going to be doing the first lesson, well, part of the first lesson in chapter 3, which has to do with algebraic expressions. So our learning target for today is writing and understanding the parts of algebraic expressions. So we're really just going to kind of understand what is algebra and what are the parts of algebraic expressions. Okay, so just some background knowledge. Translating numerical expressions into verbal phrases is an important skill in algebra. Key words and phrases play an essential role in this skill, an important role. The list to the right has words and phrases that suggest addition, subtraction, multiplication, or division. What I want you to do is pause the video and try to put each word from the list into an operations box, addition, subtraction, multiplication, or division, that you feel like it most likely expresses. What I'm going to have you do is for sure do the ones that you know for a fact, and then we can come back and you can check with the video for the ones that you weren't so sure about. All right, so at this point, if we're listening, we should already have some words in these boxes because we should have paused the video, and we're just checking. So plus. When we see the word plus, plus means addition, so plus should be in our addition box. Difference, the difference between two numbers is subtraction. Less than, okay, so 5 less than 10, again, is going to be subtraction. Factors. So factors are numbers that are multiplied together. So a factor is multiplication. Decreased by. So 10 decreased by 2 is again going to be subtraction. Times. Oops, is not addition. What am I doing? It's multiplication. Ratio. Now this one's tricky. So a ratio can be written as a fraction. So if we think about a fraction bar is division. So a ratio is also division. The next one we have is increased by. Increased by is like 3 increased by 5. We would add them together. So increased. Separate. Okay, so if we're going to separate 10 into 2 groups, we would be dividing it into 2 groups. So separate is going to be for division. Minus is subtraction. Of means multiplication. Sum is the answer to an addition problem. Product is the answer to a multiplication problem. Multiplied would obviously go into multiplication. Less. Okay, so 35 less 10. I know it sounds really funny, but sometimes we see that is going to be subtraction. We're going to see less than more likely. More than is going to be addition. So 3 more than 5 would be 8. We'd add them together. In all is usually talking about another way of sum. So we do have to be tricky with those words because sometimes it's just asking us for the answer as opposed to an addition answer. But a lot of the times when it says in all, it's going to be talking about adding. Divided is division. Quotient is the answer to a division problem. Per. Okay. So what the word per is saying is if you have, let's say, 20 soccer games total, and you have 5 games per week, we would divide that 20 by 5. So we're going to say per is for division because you're figuring out how many per week. So you'd be dividing. Subtract is obviously subtraction. Each. So for each, that can really be just about anything. So let's just take that word off, because it just really just depends on the words in the word problem and the situation that it is. So let's not even do that one, because I think that one will be more confusing if I give you an answer. And twice. Twice of something is going to be multiplication. It's 2 times something. So twice a number is like 2 times a number. Okay. All right, so now we know some keywords that might help us decide what we're doing with the letters and numbers that are in our expressions when we're writing them, which we'll get some practice on in a little bit. We're going to just go over some vocab so that when I say these words, you know exactly what I'm talking about. Okay, so an algebraic expression. All right, what that means is it is an expression. Oops. Containing at least one variable, and we're going to talk about what a variable is in a second. So a variable is a letter that represents a number. Okay, so an algebraic expression is an expression that contains at least one variable. So in the past, we've done numerical expressions where there's only numbers, so like 4 plus 6, okay, or 3.5 divided by 3/4. That's a numerical expression because it's only numbers. An algebraic expression might look something like this: 4 plus n, okay, or x divided by 6. It has a letter in it, a variable. All right, well then there's numerical expression. So this is an expression with only numbers. Okay, and examples of that are what I just kind of showed you over here. A written expression, so today we're going to learn how to convert written expressions into algebraic expressions. So a written expression is an expression written with words. Okay, an example of that might be the sum of 17 and x, where the sum of 17 and a number. Okay, which would mean that we don't know that. Right, so variables, when we are writing them down here, we don't know what they're equal to. So like when we have 4 plus n, unless we're told what n is equal to, we don't know what that's equal to, which is why we just write a letter for it, because we're not sure what that letter is equal to. Okay, and we're going to do some examples for writing algebraic expressions given a written expression. So the sum, so our key word here is sum of 10 and a number that we don't know. So the most common variable that we use, the most common letter we use with algebra is x. So we want to know the sum of 10 and x. Now we can't solve that because we don't know what x is equal to. We are just writing an expression. Okay, so sum means add of 10 and x. So we're going to have a 10 and an x. Sum is the answer to an addition problem. So the sum of 10 and a number is 10 plus x. And that's our answer. We don't know what x is equal to, so we can't solve it. We can't say x is 23. We don't know that. Okay, it's a sum of 10 and a number. Quotient is our next keyword. Quotient means divide. Okay, the quotient of a number and 12. Now when we write expressions, we write them how we read them, left to right. Okay, so it's the quotient. We're dividing something by something, and the number comes first. We don't know what number, so we're going to say x. Okay, since that comes first in our division problem. So the quotient of a number, which is x, and 12. X divided by 12. Letter C then asks 11 decreased by 5 times a number. Okay, so decreased by, if we weren't sure, we could look up into our chart from before, means subtraction. So we are going to be having 11 decreased by 5 times a number. Now we don't know a number, what number, so it's just x. So it's 11 minus decreased by 5 times x. Now see, this is what I'm saying. We should not be using an x for multiplication because now we have an x as a letter. Okay, so we can't be using that x. We could use a dot, we could use a star, you could use like a real star. However you need to show multiplication, we could use parentheses, okay, but we cannot use an x. All right, and that's how we write algebraic expressions when we are given a written expression. We use those keywords and then the numbers and the variable that they give us. Okay, or the number that we don't know is what our x is. All right. Now we're going to break down the parts of an algebraic expression. Okay, so an algebraic expression has different parts. So for example, this is a type of algebraic expression, 5p plus 4. It has at least one variable. Okay, so a symbol that represents one or more numbers, this p is called a variable. We already talked about that. Oh, sorry, I skipped over up here. Parts of an algebraic expression are called terms and are separated by addition or subtraction. Okay, so here we have one term, here we have another term. It's separated by that addition sign. Okay, so here we have two terms in this algebraic expression. The variables are the letters. Okay. The number that comes in front of the letter. Okay, the number that's in front of the letter is going to be called a coefficient. Okay, and a number in front of a letter means times. So this right here, 5p, means 5 times p. Just like we don't have to write multiplication when it's next to a parenthesis, we don't have to write it when it's a number next to a letter. It's just assumed that if it's a 5p, it's 5 times p. Okay. The last part of an algebraic expression is called a constant. It's called a constant because it does not have a variable. It does not have a letter. It's just a number. That's it. That's called our constant. It's called a constant because it doesn't change no matter what p is equal to. Okay? So for these next couple examples, we are going to be identifying terms, constants, and coefficients. I want you to follow along for at least the first example. If you still don't feel comfortable, then just follow along with the second example. Otherwise, follow along with the first example, pause the video, and maybe try the second one on your own. Great, so the terms are the parts of the expression. So our terms here would be 5x and 13. Okay. Our constants. Constants don't have a letter. So here I have a 5x and a 13. The term that does not have a letter is called a constant, which in this case would be 13 because 5 has an x with it. Coefficients. Coefficients are the numbers in front of letters. Okay, the number in front of this letter, x, is a 5. So the coefficient is 5. So the parts are terms, 5x and 13. Constant doesn't have a letter, 13, and then coefficients are the numbers in front of letters, which is 5. Since 13 does not have a letter, it is not a coefficient. All right. Number 2, our terms, again, are 2z squared, y, and 3. They're separated by addition. 2z squared, y, and 3. Our constants do not have a letter, so it's just a number. So in this case, that would be 3. Our coefficients are the numbers in front of letters. Okay, so this is 2z squared, so the number in front of z squared is just 2. And then we have a y, but there's no number in front of it. Okay, so when there's no number in front of a letter, we always assume it's just a 1y. Okay, because if it was a 2y, we'd have 2y, because 2 times y is a different number. But 1 times y is just equal to y. 1 times anything is equal to what you're multiplying it by. So that's why we don't have to write the 1, but just a plain letter is equal to 1y. So for example, if we just had just like an x over here, so if we just had an x, that's going to be the same thing as just having 1x. If we just have a z, that's equal to just having 1z, okay, and so on. So our coefficient is 2, but then also in front of this y, there is an unwritten one that we just assume is there, but we have to write it down when we're talking about coefficients. Okay, all right, I know that algebra can be kind of confusing the first time that you are learning it, because it's something brand spanking new. So you do have a practice sheet for today in class. However, if it's not making sense, you can go watch a video that's not taught by me, but taught by someone else, kind of the basics of algebra, that maybe they'll explain it in a different way than I did, and maybe that'll make more sense. So I'll explain to you how to find that video if you'd rather go watch that video before working on your homework worksheet. Okay, so if you are having a hard time, this doesn't really make sense to you, I want you to go on to Schoology. Okay, go to the chapter 3 folder, then go to the 3.1, there's a whole bunch of words after it, the 3.1 folder. Okay, I believe it is, I'll find out what color, it is like the baby blue folder. Okay, so it's the first 3.1 folder that's listed, it's the blue one. Okay, and then in there you're going to see like an extra practice / videos. And there is another video explaining the basics of algebra that you could choose to watch to have it explained in a different way if this did not make sense to you. Okay, if it did make sense, you can move on to your homework sheet, but that's just an option for if you're super confused and need some more help.